I'm going to talk about quadratic functions, which have the form f of x equals ax squared plus bx plus c. A can't equal 0. Notice that the leading term, ax squared, has degree 2. In contrast with linear functions that have the form f of x equals mx plus b, if m doesn't equal 0, the line's either got a positive or a negative slope. And notice the leading term, m of x, has degree 1. We often use quadratic functions to model projectile motion. A parent graph for a quadratic functions is y equals x squared. So if I put that in there and I plot this on a standard graphing window, I can see an upward facing parabola. If I consider the parent function y equals x squared, you can see the axis of symmetry, the line that divides the left and the right side, is the y-axis. We can also see that the lowest point on this graph is here at the origin. This is called the vertex. Let's review some transformations. So if I look at the function f of x equals minus 2, the quantity x minus 4 all squared plus 3, let's consider each transformation one by one. First of all, the x minus 4 is inside the argument of the parent function, and it shifts the graph of the parent, y equals x squared, to the right by 4. So if I look in y equals, I have my parent graph's going to show in blue, and my transformed graph is going to show in red. And you can see that this shifts the vertex 1, 2, 3, 4 units to the right. The whole graph is picked up and moved 4 units to the right. So the next transformation is the 2. We're going to multiply 2 times x minus 4 all squared. So if I look in y equals, I've entered that. So again, the parent will be in the blue and the transformation will be in the red. I expect a vertical shift to make the graph thinner. So it'll still shift to the right by 4 because we already did that, but now we'll have a vertical stretch by 2, and that's what we see. Now let's consider the reflection over the x-axis that we get when we have the negative on the 2. So if we look at that graph, notice it reflects our vertically stretched graph across the x-axis. And we'll also notice that the axis of symmetry on our transformed graph has moved. So now the axis of symmetry, instead of being the y-axis, the line x equals 4. Now let's consider the full transformed function. So f of x is minus 2 times the quantity x minus 4 all squared plus 3, which shifts it up 3. And if we look at that, we see the graph. So this doesn't change the axis of symmetry, but it does change the vertex, which is now this point. The maximum value here is y equals 3, and the vertex now will be at the point x is 4, y is 3. X is 4, y is 3. If we complete the square on our standard form of the equation, f of x equals ax squared plus bx plus c, because a can't be 0, we will get the vertex form of the quadratic or the parabola. And that is f of x equals a times the quantity x minus h squared plus k. Sometimes we want to use this form because it's easy to read off the vertex, which is the point hk. If a is positive, the parabola opens up, so y equals k is a min. If a is negative, the parabola opens down, y equals k is a max. And of course, the equation of the axis of symmetry is x equals h. In this example, I want to write the function f of x equals minus 3x squared minus 12x minus 10 in vertex form. And from that, I'm going to be able to answer all those questions. Find the axis of symmetry, the vertex, the max, the min, the domain, the range, the x and the y intercepts, and then graph the function. So in order to write this function in vertex form, I have to complete the square. The first task then is I want to get all the x terms together. So minus 3x squared minus 12x is, I'm going to kind of mentally group that together, minus 10. Now this would normally be a mental step. Next, I want to get a common factor, so I'm going to factor out the negative 3, and that will give me x squared plus 4x inside the parentheses minus 10. And I could check this. Notice negative 3 times x squared is negative 3x squared, and negative 3 times positive 4x, negative 12x. Now, whenever I complete the square, I always take 1/2 the coefficient of the x term. So the coefficient of the x term is 4. Take 1/2 of that and square it. I want you to write all of these steps. If you don't write all of these steps, you'll be much more likely to make a mistake. So that, of course, equals 2 squared, or 4, doesn't it? So now I'm going to have negative 3 x squared plus 4x, and I'm going to add plus 4, but then I'm going to subtract plus 4. And notice that 4 minus 4 equals 0, and if I add 0 to something, that's okay. I don't change it. Now the reason I'm doing this is I need a perfect square inside the parentheses. So remember, a perfect square has the form x plus a all squared, and examples would be things like x plus 3 all squared, which when I FOILed it out, it'd be x squared plus 6x plus 9. So that's a perfect square. Something that's not a perfect square is x squared plus 9. That does not, if I take the square root, equal x plus 3. Remember that what is and what is not a perfect square. I'm looking for this trinomial that is a perfect square. So I want to pull out the perfect square. So I have negative 3, and the perfect square will look like this trinomial, x squared plus 4x plus 4. Then I'll have to multiply the negative 3 and the negative 4 and the minus 10. So right here is the perfect square, and that perfect square will be x plus 2 all squared. This 2 here. So that means that is negative 3, here's my perfect square, x plus 2 all squared, plus 12 minus 10. So that's going to be negative 3 x plus 2 squared plus 2. So the parabola in standard form, the quadratic in standard form, is f of x equals minus 3x squared minus 12x minus 10. And in vertex form, it's f of x equals minus 3 times the quantity x plus 2 squared plus 2. So that means a must equal negative 3, h must equal negative 2, and k must equal positive 2. Notice in this vertex form, the vertex form is x minus h all squared. So ours would be x minus negative 2 all squared to conform with this format. So we know the equation of the axis of symmetry is x equals h, which is negative 2. The vertex is going to be the point h, negative 2, and k, positive 2. Since a is negative 3, this opens down, so it's going to have a maximum, and that maximum will be at the y value of the vertex, so that is y equals positive 2. The next thing we need to do is determine the domain in interval notation. So the domain will be negative infinity to positive infinity, all real numbers. The range, well, since this opens down, it's going to go to negative infinity, but at the very top it gets to the highest y value of 2 and it doesn't actually reach 2, so that'll be negative infinity to 2. In part F, we want to find the x-intercept, and that happens when y equals 0. Remember, y equals f of x. So that is when minus 3x squared minus 12x minus 10 equals 0. Now you can't factor this, so you're going to have to use the quadratic formula, and that will be when a is equal to negative 3, b is equal to negative 12, and c is equal to negative 10. So x will equal negative 12 plus or minus the square root of negative 12 squared, which is 144, minus 4 times a times c all over 2 times a. And simplified, that is x equals 6 plus or minus the square root of 6 all over negative 3. So written as a point, I would have 6 subtract the square root of 6 divided by negative 3 and y equals 0, and the point 6 plus the square root of 6 divided by negative 3 and y equals 0. If I want to find the y-intercept, that is when x equals 0. So I would find f evaluated at 0, and that's minus 3 0 squared minus 12 times 0 equals negative 10. So as a point, of course, that is 0, negative 10. The last thing it asks me to do is to graph the function, but just to show you these two forms are the same, have the same graph, they are the same equation. I click on y equals and I enter the standard form in y1 and the vertex form in y2. So we can see here that the equation of the axis of symmetry that we found, x equals minus 2, is in fact the point that cuts this graph in half. So this is the line, x equals negative 2. The vertex here is the highest point, and the vertex is the point negative 2, positive 2. Since a is equal to negative 3, it opens down. So the highest point, the maximum value, will be at x equals positive 2. And you can see that the highest point on the graph is also indicates to us the range, which is from negative infinity to 2. And it crosses the x-axis approximately at negative 2.80, which is really 6 minus the square root of 6 all divided by negative 3. And this point here, negative 1.8, which is actually 6 plus the square root of 2 all divided by negative 3, 0.